Well, good morning, everyone. Today is our first day of Math 151, Calc 1 class. Hopefully it's going to be fun. I should put a health warning right at the beginning, you know, when they do things that are going to be dangerous. So here's your health warning. The next 7 weeks are going to be hectic. The next 7 weeks you're going to hate me because of how much work I give you. And it will definitely reduce your free time if you're doing it right. Now, if you choose not to do that, you'll probably have a great 7 weeks, but you probably won't be successful. So you got to decide which of those 7 weeks do you want. We have a lot to cover. A normal quarter is 10/11 weeks, if you count the finals week, and we're doing it in 7. And it's not that we're going to reduce what you learn. It's going to be exactly the same amount that you're going to learn. It's just going to be crushed into 4 days, and each day is going to be longer. So that means your homework is going to be 30% more. And everything else that you're going to be doing is going to be 30% more than a normal 10-week course. So if you feel overwhelmed at times, it's probably because you are, because there's just going to be lots of stuff. But I mean, hang in there and you will get it. You will. I mean, I've done this enough times to know that it is possible. So I'll do a quick intro and then we'll jump right into the syllabus, covering some of the stuff you need to know. We'll do Canvas, talk a little bit about the resources I have there for you. Then we'll go into WebAssign, which is essentially where all the good stuff happens. That's where all your homework is and your tests and a lot of other things. And then hopefully we can get started on our first topic, which is the beginning of chapter 2, and it's a tangent line problem. So that's kind of my goal for today. So let's start with me. My name is Donald Robertson. And Robert, do I have an accent?
Not yours, no. We're the ones with the accents.
See, Robert knows. And if you're wondering where I come from Scotland. And I kind of like to do this one at the start. We are, separated by a common language. So for some of you, it might take you a day, but hopefully no longer, to get used to the funny way I talk. But after that, you'll pay no attention to it. It's just the way I speak. Most of the words we use are identical. I'll use some words like we when it means small, but nothing major, I hope. And most people know what I mean by the context of the words around it. But there are a few things I'm kind of sticking to. It's J, not J, and it's Z, not Z. And it was my alphabet before it was yours, so I am right and you are wrong. Just thought we clear that little hiccup up. Some of my students, at least in my Calc 4, although in other cases it's earlier, have now decided that they're just an extra letter of the alphabet called Z. And so they kind of say that. Some people have told me, quite a few actually, that when they're doing their homework, they hear a little Scottish voice while they're doing it. And you should be worried about that because it does go away after you stop getting me, so it's nothing serious. Put Robert in the spot here. Robert, when you had me, did you hear a little Scottish voice when you did homework?
No, but I watch a lot of British television, so I'm fine with Irish, Scottish, Welsh.
So you're used to that then. For some of you, it's a little bit stranger. Okay, so let's hit the buttons and jump right over to, I hope, Canvas. So if you're looking at Canvas, everything is good, all right? I'll just take a window, and what I tend to do is I just look at your faces, and if you nod, that's enough. Are you seeing Canvas right now, guys? Right, now the fact I'm going to be looking away from is because the screen is over here, and so don't pay much attention to that. Now I'm going to go into student view, so it's a little bit closer to what you've got. That's still good, guys? Nothing disappeared, right? So if you've been to Canvas, you'll see that it's made up of, in our case, 3 modules. The bottom one is got all the college stuff that can help you, support and so on. The middle one is basically resources that I have picked up that I like, that I've put here for you. So for instance, if you click on this one, which is chapter 2, if you want to click on, say, this one, you'll see that I've got some videos videos produced by other people on the same topics. And if we go down here, you see that I have some basically PDFs of notes. If you click on, let's say that one, for instance, I got the thing right. Okay, click on that one. There we go. Open it up. Make it bigger. There we go. And there's some notes on average velocity and instantaneous velocity, which is basically some of the things that you'll find in 2.1. So these are essentially just resources, right? You can choose to not even look at them or to look at whatever you want, but it's there, right? So that is a resource, our class resources. The second one is your college resources. And then if we go to the top one, if you've been here, you click on this guy here, and what you should see, and here we go, is basically an intro and how to get access to WebAssign, how to join it. Now, since all your homework's going to take place there, all your online tests are going to be there, that's a big part of the class, right? So you've got to get that joined as soon as you can. Now, financially, you might not have got your student aid through or whatever. You do get 1 week free. So when you join WebAssign, it'll give you the ability to not need to pay for a week. So it gives you a chance to do that. Plus, I mean, if the class doesn't work for you, maybe it's just time schedule, you can drop the class and you haven't forked out a lot of money, right? So it's kind of helpful. Now, if you've already paid for it, hard luck, you're staying in this class now. You're not going to lose that money, right? You're going to make it, you're going to get some good out of it. So that's one of the things we have. If you're interested in a little bit about me and why I talk funny, here's a little bit of Culture of Scotland. The main one is probably this third one here. And this link, here is the link that you got to come to this class. So that's repeated. And here you will find eventually all our lessons. So for instance, when you go in this evening, you will find that this will be populated by the video that we're doing right now. So if half the things I say go because I'm saying so much, can't you just go back and pause the video and say, oh, okay, that's what you meant when you said that, or I'd like to see example 2 again because it didn't sink in the first time. So it's a place you can go to watch all our videos. And I am making the assumption here that everybody here is okay with the video. It'd be kind of hard to do the class without them, so I'm assuming that you made that commitment when you came. So hopefully that's true. Okay, so this is basically the Canvas part done. Is there anything about that you want me to go into details, or is it pretty obvious what it's for? We good? Okay, now let's go over to the syllabus. Now there's an awful lot of information in this. I'm not going to read every single line. You go and have a look at the syllabus when you've got time, right? And read it. I'll just give you the big overview. If you want to talk to me, ask questions, then you have to use this email address, which is our college one. You'll find in WebAssign, they've got a button that says ask a professor or something like that. I've never figured out how to make that communicate with me. I mean, you might type things in and it just disappears into the ether. It doesn't get to me. I think the only way I can find it is if I go into WebAssign, then I have to hunt through a couple of levels to find out if anything's there, and I very rarely do because I'm lazy and I forget to. So just send everything to me, drobertson@olympic.edu. There is an unofficial officer. I don't actually get paid during the summer for officers, but they're there anyway. So essentially before the class starts, you can catch me. That's maybe not going to work for you. So if you do have a problem, you just email me and say, hey, can we have 10 minutes? I need to talk about something. Or you could just send the question. If it's simple, emails work fine, right? If you say, I'm on question 4 and I've got 4x plus 1 and the answer said 6x plus 1, what am I doing wrong? But I could probably answer that back by email. But you can imagine that calc one's a little bit more detailed than, just normal arithmetic or algebra. I might just say, okay, here's a little video link. We'll do the video for 5 minutes and I can write it all down and you can, answer your questions that way. So that's the way I'm going to be helping you. Officers are great. See me every 4th class. Otherwise, tell me when you want. The next one is you should be able to get into this class. So do you have the right prerequisites? Check them. If you don't have them, we will end up dropping you. It might take a few days for the people who do checks for me to send in. John Smith doesn't have the prereqs, but it's pretty obvious. You need a pre-calc 2. You need to have done trig or Accu-Play series or some kind of testing score. All the good stuff. Well, the fact that you're all here, you've got that stuff, so we can say that. We do have college-provided resources. So if your mic dies on you or you need a webcam, you want to contact IT and they'll give you a loaner. This bit here is about WebAssign. We start today, we finish on the 18th of August, and that day is actually the exam, the final exam. And there's going to be a 3-hour midterm on Monday the 25th. And what you're looking at here is, as best I can predict, all the topics that you're going to be doing during this 7 weeks. And they're called simply week 1 to week 7. Here is ours. For instance, this week, my goal is to cover these 3 sections. And they'll all be homework and they'll all be in WebAssign. So if you've never done WebAssign, that's kind of where I'm going to go after this, right? We'll show you what that's like. I mean, it's basically you get questions and you type in answers. I mean, it's just like homework. You just type in answers. So we go to that. There's your final. This is what you're going to learn. So hopefully when the class is finished, you can go back and look at learning objectives and say, yep, we did that. Don't cheat. This is how you're going to get points, make prizes. Turning up, participation, taking part, is going to be 10% of your grade. And we do that by simply, you come to class as you are right now, so you've already got your first participation point. And after the 7 weeks that are finished, if you turned up every single day, you'd have 10% of your entire grade. We have homework, another 20%. At the end of each week, there is an online test. Homework and online tests can be done anytime, right? It's open until midnight on Sunday. Midnight on Sunday is the end of week 1. Midnight on Sunday is the end of week 2 all the way through. Only difference is the last week, it's not midnight on Sunday because we finish on a Thursday, right? So we have a little difference there. And there's a 3 hour, 20% on that and 30% on that. So you see 100% of your grade, and that's how it breaks down. You get participation points, and I expect you to be here, but if you don't, then you'll lose part of that grade. Here's our link. Homework's on WebAssign. Online tests are on WebAssign. The midterm and the final are different. They actually are going to take place like what we're doing right now. The only difference will be that the test will be on Canvas as a PDF, and you'll write your answers down on paper and you'll upload it to me. And when we get closer to the time, I'll show you how you do that. But there are some software that you would want to practice on that. And then you add it up and you get your grade. That's how you turn it into a letter. And we have e-tutoring. If you know people in this class or get to know them, you can use them as study partners. And WebAssign has tons of stuff as well. Keep to the schedule. Do not get out of sync. You know, if you get 3 days behind, next week you've got a whole week's worth of stuff, plus the last 3 days, you'll just get overwhelmed. So keep up, and that's the best way of going through it. Organize and plan your time efficiently. I do not want to get an email from one of you saying, I spent 3 hours on question 7. Can you now help me? You should be saying, I spent 15 minutes on question 7. Can you now help me? Right? Because if you don't know it by 15, you probably won't know it by 3 hours, right? So I'm exaggerating, but you know what I'm getting at. You only have a limited amount of time. You have to be efficient with it. On that vein, then, I would suggest strongly that once we've done a topic, like a section, that you try the homework as soon as you can, because it's fresh in your brain and it'll go quicker. And if you've got a problem, you've got time to contact me. It's a little bit difficult if you try and email me at 10 o'clock on a Sunday and say, I need help now. I just won't be able, I wouldn't even be about to know that you asked that. And usual accommodations that we give. Right, I say a lot in that, more for you to read. Any questions? We good? Looking at faces, we're good. Okay, let me return back home and open this one for you again. And there's our office hour link. If you need some help on WebAssign, there's a page for you. If you need to help with Zoom, here's the page on you. And what we have here is the software that you'll be using during the midterm and the final. That's only 2 times you're going to use it. And basically, you upload this app onto your phone, you take pictures of your working, it converts it to a PDF, and then you will upload that PDF into an assignment that I have, which will appear when we need it. And I'm now going to leave student view. I'm going to go into this one. And I'll do this as a student view as well. So this is what WebAssign should look like. Now the instructions about how to join WebAssign are in Canvas. It's that top one that says, Math 151 information, right? Just go through it. So we'll assume that you have done so. And this is what it looks like. You see that this week is the only 3 that you see, and you see it even tells you when they're due. If you wonder why there's a 56, 57, and 58, I found that if you make them all the same, it's hit and miss that you get them in the same order. So you'll get things like 2, 3, 2, 1, 2, 2, and that throws everybody, including me, right? And you can imagine 2 or 3 minutes is going to make no difference to your life, right? So that's the only reason that's got a little kink. And there are 3. And eventually you'll be able to hit a tab and it'll tell you all the past assignments. So if you want to go back and look at something, you'll be able to see them. Now I'll click on this one. And it opens up. And you can see that in this particular one, there's a video that you can watch. And that will help you answer this question. And this one here is what they call a tutorial exercise, where if you click here, there we go. It takes you kind of step by step, so you fill it in, and when you're ready, you submit it. Right? If you want extra help on something, you sometimes get a read it box. Sometimes you get try another example box. So it gives you a practice one that you can practice, and then you can go and do the real one. So I'm just going to hit this one. It should jump to the ebook. That's what they typically do. And with a bit of luck, yes, it jumped to the right part of the ebooks, right? So this is D1, and read stuff, tells you good stuff, right? Essentially all that. So hopefully I can just cancel that and off we go. Now let's make up a question. Let's not make up, let's make up an answer, right? So suppose I think the answer is 1.58. Right, I did my calculation. Do you see how easy it is? You just type it in the answer, 1.58. Now, I know that's wrong, but pretend it was right. I would just go submit answer. And it's not very helpful, but it did tell me I'm wrong. But you get 5 shots. So you'll say, oh, I know what I did. It was 1.85, which is also wrong. But you keep doing it, you get 5 shots, right? So you should know what to do. If you are not comfortable why you're wrong, do you see it gives you some backups? Can you read the ebook? You know, maybe get any more detail and say, oh yeah, that guy goes in, not the other one, right? Whatever it was. Watch it. Master it, right? So you get other benefits. So it's not just, here's a question, give me an answer and I'll tell you nothing, right? It's pretty interactive. It'll tell you when you're wrong and it'll give you choices of other resources, right? For instance, couldn't I just practice another version? And so I could do these ones as many times as I like, right? And then once I figure it out, I can then close that guy and go back and put in whatever the right answer should be, and it'll be good. Does that seem intuitive? That it kind of makes sense how you would use it, all right? There's nothing too weird about it. This section is mostly numerical, right? So yeah, the problem with numerical is I can't show you a guy I want to show you in this one. So I'm going to leave this one, hit home, and then I'll close student view. And I'm going to do this one. I know we're not doing this until the end of the week, but I just want to show you one more thing. Okay, so are these going to be numbers? I want one that isn't a number. Okay, this one isn't. Good. There. You notice when I click this box, this funny calc pad appears over here? Because sometimes your answer isn't going to be a number, isn't your answer? It could be the square root of x plus 4. Or make sure it's not in capitals. X plus 4. And see, that's how you would do that. Now, it could be a fraction. It could be x squared, right? And actually, if you look at this, I've got to on tell me the answer. So the right answer is just 3x squared. But can you see that you would be able to use this? Now, this calc pad has a number of little sub-menus. So this one here gets you to do fractions, powers, square roots. You don't need to worry about factorials, you won't do those. If you go here, you can get cube roots, absolute values, e to the power, logs. You know, you might have an answer that's a log in it. If I move down, well, you know, you want to say infinity sometimes because that might be the answer. You won't use all of these. You might want greater than or less than occasionally. Yeah, I guess you could do union and intersection. You won't do vectors. You might want to do sines and cosines and things, right? So, oh, and if you hit this guy, you get all the Greek letters. So this little guy over here, the calc pad, is going to be your go-to guy when your answer's not just a number, right? So if there's something algebraic involved. Okay, do you feel comfortable about this WebAssign homework thing as just homework where you type in numbers or 5x plus 1 if that's the answer? And getting lots of nods, which I really like, it makes my life easier, means it makes sense. Is there anything that you want me to talk about in this then? Are you cool with WebAssign? Right.
I was wondering how many attempts we get at a problem, and same with the test.
In the homework, you get 5 shots for each question. Okay. As far as the test goes, you don't, well, you can have an unlimited number of shots, but the test, oh, the online test? Okay, I misinterpreted what you mean. The online test has also 5 shots. The difference with the online test is it won't tell you that you're right or wrong.
Okay.
So if you put an answer in, then you say, oh God, I meant to put 42. You can just type it in 42 and, you know, it will only remember the last answer you said, right? So in the test, if you change your mind, that's fine, but you get 5 shots.
Okay, thank you.
Okay, now if it's the midterm or the final, that's done totally differently because they basically, I look at your working. So you can take as many tries as you like, but you know, you have a time limit, so you want to, you know, be efficient. Anything else? Okay, then I'm going to stop sharing that. And now we're going to switch over. Okay, just do smoothly here. Can you see me, guys? And I've got a little circle of death going on. If this doesn't fix itself, I'm going to just leave Zoom and come back in.
Did something happen?
I think so. I think he said he's going to leave Zoom and come back in because he was having a problem.
Hi guys, I'm back. I think I am anyway. You see me again? Things were going far too smooth, agree? You can't have things going smoothly. It just doesn't work that way. Okay. Now I'm going to try jumping over. It might be a camera issue with me, which will be a real pain in the butt if it is. And things look like they're moving. At least I can see 151 syllabus and stuff here? Right, we are cooking. So we're going to start with our first section, which is called the tangent and velocity problem. It's actually the tangent line problem. That's what I would have called it, at least. So, what is Calc 1? Is a good question to ask yourself. Well, calculus in general started with a problem called the tangent line problem. Superficially, it doesn't look like a big deal when you see it. I'll give you an example of what the problem looked like. So you're going to think 400 years ago, someone come up with this problem. Let's suppose we have a function. We won't give it any specific details. Y equals f of x, right? You know, it could be x cubed plus 2x, right? Whatever it is, there's a curve. And we would like to know this is the problem, the exact value of the slope of the tangent line at a given point P. And let's suppose that P was here. Right, if you want to know what a tangent line is, I'm pretty sure you know, but if you wanted to be reminded what it was, a tangent line is a line that just touches the curve, right? Doesn't cut it, just touches it. And we want to find the slope of that line. That's called the tangent line problem. So you might say, wait, that's not a difficult problem. I'll just get out my ruler and I'll draw a tangent line. And then I'll do a little rise over run thing, right? Let's pretend that that's 5 and that this is 10, just for argument's sake. Then I could say, okay, M, it's the letter we typically use for slopes, is rise over run. And I would say, what's the problem? The slope's a half. We don't need calculus. Well, they'd have to know the future to say that. We don't need anything special. That's the tangent line. Well, the problem with that is that if I gave Madison the job, isn't there a very good chance that Madison's line, tangent line, was a little bit different than mine? Couldn't yours be a little bit steeper or a little bit shallower? And then I give it to Coral, and guess what? Hers would be, and even if the difference is 0.02, right? In the, thing you might not even notice, the thickness of the ink, right? Can you see that there isn't any clear correct answer to the exact value? And that's called the tangent line problem. And we are going to be spending 2 weeks either directly or indirectly solving that one problem. Because that's where calculus is going to start. Because once they figured out a way of solving that problem, they then came up with a process that's called differentiation, which is what that does. Differentiation allows you to find the exact value of a tangent line to any curve. And that's derivatives, and that's what Calc 1 is, differentiation, derivatives. So it's kind of remarkable that the whole foundation of calculus, differentiation, started life as trying to find the tangent line on a curve. Right? You might have thought it should have came through some really big, highfalutin, complicated situation. No, it came from a very simple situation with a very complicated solution. So That's our goal. But we're not going to go right into getting the exact value. We're going to take it in little baby steps. So we are going to find an approximation to the tangent lines, to the slope of the tangent line. Now, to be able to find an approximation to that, I need to introduce some terms. So let's show you one of those terms. So let's imagine we get another curve, that one there. And this point here is the P that we're interested in, right? And let's suppose it has coordinates 2, 3. And I'm going to pick another point in the curve. I'm going to call it Q. And this one is going to be 5, 7, right? Just for argument's sake. Now, if you join 2 points on a curve with a straight line, that straight line joining P to Q is called a secant line. So any 2 points on a curve from P to another point Q is called a secant line. And we are going to find the slope of the secant line. Now, since they have fixed values, right? I know the coordinates of P and I know the coordinates of Q. Can't I find the slope of this line, right? It's not a guesstimate, right? P is at 2, 3, that's not moving, right? Q is at 5, 7, that's not moving. If you put in your little vertical dotted line, guys, this distance is called the rise. This distance is called the run. And so if you want to find the slope of the secant line, and let me show you the most common notation, M, P, Q. Whenever you see M, it means the slope is something. And so this is the slope of PQ. I get distracted easily, so let me get this out of my head. There is no reason in the world why it should be M. Shouldn't it be S of PQ, right? Slope of PQ, but it's called MPQ. And I made this up before. I think it must be the French. The French for line or slope starts with an M, and they got in first. So once somebody does something, especially when they're the first people to do it, don't we all just agree with the same notation, right? So if you're wondering why it's called MPQ, make up my pretend answer. It's because of the French, right? So that means the slope from P to Q. Now, that would be rise over run. Now, I could probably do a quick count in boxes here. If you look at that guy, it's 7, and that guy, it's 3. We agree that that distance from 3 to 7 is 4. And if you look at the x coordinate, that's 2 and that's 5, and the distance from there to there is 3. And so the slope of that line would be 4/3. Are we cool? Now, let's do a general version of that. Suppose P had coordinates xp, yp, and let's Q have an x coordinate of xq and a y coordinate of yq. And I want a formula for the secant line PQ, the slope of it. Won't it be the difference in the y coordinates? Isn't that basically the rise? And do you notice it's Q take away P, right? that way, over xq take away xp. Right, let's see how that formula would work. Yq is 7, take away yp is 3, xq is 5, xp is 2. Now, the reason why it's kind of helpful to have a formula like this is, can you imagine that P and Q aren't going to be nice numbers all the time? Couldn't P be 2, 3, but Q might be 3.007, 6.998, right? And trying to do rise and run with really awkward decimals or fractions becomes a bit of a pain. Isn't it better if you just plug the numbers into a formula and then let the calculator sort it out? So we have a secant line. So suppose I wanted to do a more accurate estimate of the secant from P to Q. Oh, by the way, not the secant, I should have said the tangent. Now I'm running short of colours here, so I'm going to have to go purple, I think. If you looked at the tangent line at P, can you see it's a little bit steeper than the secant line PQ? But would you agree that it's close? In other words, it's an estimate, right? So if I wanted to improve my estimate, hold on, everyone.
I have that same headset.
Oh, well, we did first already. That's still good.
Sorry about that. The problem with teaching from home is that things happen. So back to where our thought process is. I want to get a better estimate for that tangent line. So I've got P and Q, and we're talking about the tangent line at P. So that's not going to go anywhere, right? That's still going to be 2, 3. But I do have control, don't I, of where Q goes. Agreed? Now, if I wanted a better estimate, would it make sense that you should choose a Q nearer to P? So maybe I'll choose my Q here. And this time it's 4.9, right? And I'm going to take, that's the tangent line. And here is my secant line. And this new guy, this new secant line, is going to be my second estimate. And so what do I get? I get 4.9 take away 3, and I get 3 take away 2, and pretty much going to guarantee that I'm going to get, there we go, 1.9. Now, if I keep doing this process, couldn't I pick another Q even closer to P than that one is? Couldn't I have told, you know, Q is 2.1, 3.6, right? And then Q is 2.001, right? And whatever the Y coordinate is. Now, as long as I have a formula for the function, can't I pick any X value I like close to 2, and I'd be able to find out what the Y coordinate is? And that was the first strategy, to finding the slope of a tangent line. You got P, you can't move them, right? But you can pick Q to be as close as possible. And then some bright spark said, hey, I've got this problem sussed out. If I can make Q really, really close to P, I get a really, really good answer. So if I made Q on top of P, shouldn't I get the perfect answer? Now let's see what that would look like. P is 2, 3. And Q is going to be also 2, 3. And they tried to find the secant line. And this happened.
Won't that be 0?
It
Yeah.
will. And I can just imagine the poor guy's or poor woman's brain exploding and going, darn it, I thought I had the thing solved. Would you agree 0 over 0 is not a good calculation? I know the answer is not 1. I know it looks like if the top and bottom number are the same number, the answer is 1, but not when those numbers are 0. So can you see that that approach kind of failed? We can get really accurate answers using this approach, can't we? Just pick Q 2.002 and we're good. But we can't do a perfect answer, right? We can't get an exact answer because nobody knows what 0 over 0 is. So we are going to just forget for a little while the goal of getting a exact value. And we're just going to settle for good estimates. And there are 2 types of questions that are going to involve settling for a good estimate, right? One of them is going to be using functions. So we're going to get questions where we're asked to find an estimate for the tangent line at a given point P, and they're going to tell you, and I'm picking a nice easy one for calculations, that the function is y equals x squared, and we are interested in the slope of the tangent line at the point 3, 9, right? And the second one is that we're going to find, I should put out what we're going to find here. We're trying to find an estimate for the slope of the tangent line. And I'll just call it TL for sure. And the second one is we're going to use a table of values. So we won't have a formula. All we'll have is a table with numbers in it. And we're going to try our best to estimate the slope of the tangent line in that situation. And let's just say that it's at 3, 9 again. Right? Okay, let's do the first problem. So example 1. Is find an estimate for the tangent line. I should say the slope of the tangent line at the point 3, 9 on the curve y equals x squared. Okay, we all comfortable with what the puzzle is. What we're trying to do is, what's a good answer, right? An accurate answer, not a perfect answer, but a nice accurate one for the slope of the tangent line at this point on that curve. And bear with me for a second. I'm going to do a little function here. Okay, that's not the one I wanted. I hope you've used a program called Syllabus. If you haven't, it's a very easy program to use, and I'm going to show you presently. Here we go. What that looks like. Since a lot of what we're doing right now is, in my opinion, quite visual, it's kind of helpful if you can see stuff. Right? It's not, you can do it without having a picture, but it's kind of helpful. Right, so in Syllabus, you just type in y equals x squared. There you go. Move it around a bit. There we go. I'm interested in, I think, the 0.39. So there we are. There we go. You see it? Maybe shrink it back a little bit. There we go. Now, if I was trying to do a line, tangent line, would you agree it would be something like that? I'm going to draw it right now. Looks like that. That's what we're after. Now, I'll nip back and let's do the math then. So we now kind of know what we're trying to find, right? We have a point, 39. And now I'm going to pick another point, Q. Now, if I want a really accurate answer, shouldn't Q be very close to P? The logic, closer you are, better your answer. But if the question was open-ended, right, couldn't you just pick any number you like? But very often what they do in these questions is they tell you to use x is 4, then x is 3.9, then x is 3.1, and then x is 3.001, right? They give you a whole list from start to finish. So you end up doing it 10 times, which is very laborious, but that's the way they do it. And we're going to cut some corners and pick somebody close. So who am I going to ask to help us out here? William, give me a number. And remember, I don't want to be spending 10 days doing it, so don't make it too weird. Give me a number close to P, an x coordinate.
4.
Okay. 4 is easy to calculate. So I'm now going to find the slope of the secant line. And it's going to be 16 take away 9, 4 take away 3. You've made my job very easy. Thank you. And so, right, that's an estimate, right? Right, someone's going to make my life a little bit harder because I want them to. I want something closer. Robert, give me a closer than 4.
3.01.
Right. Now, would you agree 3.01 is almost on top of 3? Right? If you try to draw it, you'd have to get a magnifying glass to see, you know, the two dots separated, right? They'd almost be on top of each other. And of course, I need to figure out what the y coordinate is, but 3.01 squared is not too bad. The answer is 9.0601. And so the slope of the secant line joining these two guys is 9.0601, take away 9, and 3.01, take away 3, which is 0.0601 divided by 0.01, and that ends up being 6.01. So the slope of the tangent line, our first estimate is at 7. When we picked a guy really close, it's now 6.01. And I am going to do it one more time, although I'm going to regret this, but you have to kind of do this. I want an even more accurate answer, or estimate, than 6.01. Hatsune, you got the job. Give me the x coordinate that's even closer than that one?
Well, 3.001.
No one has imagination. Do you know you could have a 2 there if you like? But I'm not changing it because that's what you gave me. Now, on a calculator, the y coordinate of that guy is going to be 9.2 zeros, a 6, 2 zeros, and a 1. And the slope of the secant line joining those two guys is going to be 9.006001, take away 9, and 3.001, take away 3, and that ends up being 0.006001 divided by 0.001, which ends up being 6.001. Now, there's a fancy word in mathematics called conjecture. Conjecture is just a fancy word for guess, but it means intelligent guess. You just say, you don't say, 42, right? If you were going to make an intelligent guess, right, or conjecture, what do you think the slope of the tangent line is probably going to be?
6.
Would you all agree that 6 seems to be the best candidate? Now, have I solved the tangent line problem? Well, you might think you have, but the answer is still no. And the reason for that is, couldn't conceivably be that the exact answer was 6.42 zeros and a 17. I mean, theoretically, couldn't it be that? There's no way that you know that it's not that, because aren't you always going to get some kind of answer? And the closer you make Q to P, won't this answer keep changing a little bit? So we have got a very good way of estimating, haven't we? And doing a conjecture. But we've no guarantee that that answer is definitely the exact value for the slope of the tangent line. What we can say is we're like 99.9% sure it's 6. And at least can't we say we're certain that it's close to 6, right? I think we could say that for sure. We're certain that it's close to 6. And we're 99.9% sure that it probably is 6. But isn't there a 0.1% chance that it's just some other number that's very similar to 6, but a little bit different at the same time? Do you see how difficult this tangent line problem is becoming? Right? We got a way of kind of narrowing the answer, and we get to a point where we think we know it's probably that, but we haven't got to a point where we can say it's guaranteed to be 6, right? That takes a while, and that's not going to happen today. The second way, and actually the more common way that we're going to be doing it, is using a table of values. So you're going to get questions that look like this guy. So here is a table where over a 1 second period, they measured increments of what, 0.2, the temperature of, say, a chemical reaction, right? So at the beginning, it was 5 degrees, right? Pretty cold. Then 0.2 seconds, it's that. By 0.8 of a second, it's now that. And by the 1 second mark, it's now that. Right? And we are interested in essentially finding the slope of the tangent line at the point here. So at that point, which I'm going to call P. Now, they might not use this particular way of saying it. They're likely to say, find the rate of change at t equals 0.4. The phrase rate of change and slope of tangent line are synonymous, right? They essentially mean the same thing. Isn't rate of change difference in temperature divided by difference in time? You can see it's like rise over run. So it might look like you're being asked to find something different, but you're not. You're going to be finding the slope of the tangent line. We're going to do it using this secant method. And we're going to find the rate of change at t equals 4. Now, what we don't have control over now is who Q is, right? Because can't we only pick, and think of this as a coordinate, right? Q could be this guy, Q could be this guy, this, and this. So I'm going to add a little extra column here. Right, now you can't do that one, right? So I'll block it out. You can't have Q being the same as this fella, right? That's not going to work. But couldn't I make this my Q and get the slope of the tangent line? I could make this my Q. This could be my other point, right? This could be my point, or even that one. Now, of all the ones I could choose, would you agree I'm more likely to get an accurate answer at this point here and at that point there? And the reason for that is, aren't these two closest to the point 4? So let's start with Q being 0.2 seconds, 6.2 degrees. P is still 0.4, 7.1. And from these two, so I'm using that guy as my Q and this is my fixed P, we can now find the slope of the secant line. And it's going to be 6.2 take away 7.1 and a 0.2 take away a 0.4. And that's going to be 0.9, and I should say negative 0.9 over negative 0.2. And that ends up being positive 4.5. So this one is a rate of change of 4.5. Now, if you want to know what this is telling us, is that from the 0.2 second mark to the 0.4 second mark, isn't the temperature increasing at the rate of 4.5 degrees per second? Right, pretty good. Now, let's try on the other side. So P is 0.4, 7.1. Q is the point 0.6 and 8. And so the slope of the secant line from P to Q is 8 take away 7.1 over 0.6 take away 0.4. In this case, it's 0.9 over 0.2. And I wish I had planned better, because that's also 4.5. Can we pretend that that was 4.1? Right, would you agree there's no reason they should be equal, right? Couldn't they be a little bit bigger, a little bit less? But based on the fact that these are the two best places to look, couldn't we then estimate it? And our estimate would be based on this example. Wouldn't we estimate 4.5 as the best, most accurate estimate I could give for the slope of the tangent line at 0.4? or a Z3 is the rate of change at 0.4. Now, if this had been 4.5 and this other one was 4.1, what do you think I would have done? This answer is 4.5. This answer was different, 4.1. What do you think I would have done as my conjecture, my best estimate?
Average.
Yeah, wouldn't that be the best thing? Because I don't know if the first one's better or worse than the second one. I have a number 4.5, the other one says it's 4.1, put them together, 4.3. Now, when you have a table of values, would you agree that you can only, your accuracy is governed by your table, right? If your table's got lots of numbers really close to each other, you're probably going to get a good estimate. But if your table is, you know, to the nearest whole number and there's 5, 10, 15, 20, aren't you going to get a really crude answer, right? You're not going to get a good one. Can't avoid it. You only, what's that? You can only shoot with the gun you've got, right? So if it's a bad data set, you're stuck with it. Are we good? Any questions so far? Right, let's zoom back now and show you what the homework questions look like. Okay, I got a window issue. Right, okay. Right, are you looking at 2.1 tangent lines? Am I seeing nodes? We are, okay. So in this one here, you've got a video to watch and it's a table of values. So it's very similar to the one I've just did. Can you see that they've calculated? They're calling this guy R, I would have called him Q. In fact, most of the other questions, they call it Q. And they take you through a lot of the calculations have been done for you. But if you look at this table, can you see that we're interested in what's happening at the 0.4 mark, right? 0.04 mark. So that would be in here if it had a value. Now, can you see at one side, it's that negative number, and at the other side, it was this negative number. And so can you see what they did there is they averaged it out. Now that one kind of gave you a lot of stuff. So here's one where it didn't give you, here's one, didn't give you much, right? This is a 3,000 gallon of water tank, which is drained from the bottom, and it takes half an hour to do it. So at the 5-minute mark, there's still 2,000 odd left, right? By the 20-minute mark, it's down to 354, and after 30 minutes, it's empty, right? So you can kind of imagine the tank draining. Now, if you know anything about big tanks of anything and you drain them, doesn't the water shoot out like a bullet at the start? Because there's a lot of water and it's pushing down and gravity and all that good stuff. But towards the end, doesn't it kind of trickle out? So this is not going to, you know, the rate at which the water is leaving that tank is going to change from time to time. In this story, we are interested in what is happening at the 15-minute mark. Do you see why 15-minute mark is missing? Because you can't do a slope from itself to itself, right? I would have put that table in and then just cross-hatched it out, right, saying you can't use me. But, you know, it's just a detail. So let's take this one. If you want to find what the slope of the secant line from this P to that Q, it would look something like this. It would be 2070. Take away 765. Divided by 5, take away 15. Now you do not need to do that in WebAssign, right? WebAssign, you just do that in your calculator. which is what I'm going to do now. And I'm going to do a bracket around it, 2070, take away 765, divided by, put another bracket, 5 take away 15. And the answer I get is negative 130.5. So I'm going to rub all of that out now and do negative 130.5. And that's it. That makes sense how I did that? So the only thing you'll type in would be this one. Now, the reason you don't get your little funny guy over here is it's a number, right? And if it's just a number, it's not going to give you that little calc menu thing. So far, so good. Right. Now, you do that one, and I'm making these numbers up. So that ends up being negative 100 because I said it was. I know it's totally made up. This one is negative 90. This one is negative 20. And this one is negative 10. Now, although these numbers are made up, what won't be made up is, do you see the speed at which the water is leaving is reducing, right? I would assume that that's what you would see, right? Secondly, if I am going to estimate what is happening at the 15-minute mark, shouldn't the only numbers that I pay any attention to, because they are closest to the 15-minute mark, shouldn't it be those two? And they're not the same, which is what I'd expect, but when they're not the same, don't you just average them out? And that's what that would look like. Why are the numbers negative and not positive?
Slope is going downward.
Right? And the slope's going downwards because isn't the liquid leaving the tank? So if things are reducing, going downwards, shouldn't the slope be a negative number? Now, if it was filling up a tank, right, you might tell a different story. Wouldn't it be going up the way it'd be positive? So if you know in your mind that the answer should be negative and you get a positive answer, will you stop there and say, I better check my calculator? I think I may have done something wrong. And I'm going to show you a mistake on my calculator. I do lots of mistakes normally anyway, but this one's a deliberate one. Right, there's the correct answer. Do you see it? Now, 2070, take away 765, divided by 5, take away 15. Now, in a lot of ways, doesn't that look like the same calculation? Do you see it is a big positive number? Shouldn't that be, I better look? And what I've not done is put, yes. You know, order the calculations, you have to make sure that you do things in order. And isn't what those brackets, the top one up here is doing? It's making you subtract those two. It's making you subtract those two. And then lastly, you're going to divide. What the calculator thinks this calculation is, it says, oh, you want me to take 2070 and subtract 765 divided by 5, right? Subtract whatever that fraction is, and then take away another 15. And so order a calculation, right? PEMDAS. Easy to, you know, easy to screw up because, you know, very often they look the same. They're even more dangerous, aren't they, when there's only a single number in the top? Doesn't it start looking much, doesn't that look correct, right, if you're careless? It's not. You see the difference? So, you know, when you're doing your calculations, order the calculations. I always work on the principle, you can't do damage by giving something some brackets that it might not need, but you can do a lot of damage by missing them out, can't you? So if you're thinking, I wonder if I need one here, just give it a bracket, right? Stick a bracket at the front, stick a bracket at the end. You're not going to kill it, right? If you didn't need it, calculator won't give you the wrong answer, right? You'll still get the right answer. How are we doing, guys? You feel comfortable about this one? Right. Now, there's another table. Now, here they talk about secant line 040, right? And secant line 1020 and secant line 2030. So you've got to be careful about that, because if you're not looking too carefully, you might think of that as a coordinate, but there's no P. It's not actually a coordinate.
Professor, you're still on the paper.
Oh, thank you. That I need to know. So the next question I was talking about is question 4, where you are going to find the slope of the secant line joining these guys. So when it says 0 to 40, that's 0, right? This guy here is 0, and this guy here is 40. Can you see the P and the Q? And then when they do this one, can you see 10 is like the P and the 20 is the Q, right? So that's what you would do in those questions. And then you do that one, and then you're going to estimate what's happening at 3:20. So that should be, since it starts at 3 o'clock, 3:20 is basically what's happening here, right? Your best estimate. Now, on this guy, isn't that like the first one we did today? Right, remember the P39 and the Y equals X squared? Here is P is fixed. And this number here is the X coordinate of Q, right? So let me show you how you would do that with the least amount of work, because it's quite boring and intensive if you have to do every single calculation one at a time. So there is some shortcuts. So clear this out of the way. Y equals, clear this out of the way. Now the function that they're talking about is 3 over 4 minus x. So there's 3 divided by bracket 4 minus x. Do you see ordinary calculation again, right? You need a bracket. Then you go second table setup. And the only thing you really need to do here is whatever you're meant to start off at. So you can do anything you like, but basically, as long as that says ask, you're good. So you can table start at 40 if you wanted. That's not a big deal. But make sure that says ask. And as soon as that's done, you can then go second table. And I'm going to delete these from previous question. And I'm going to put in 4.9, 4.99, 4.999. Do you see I'm getting all the X and Y coordinates of the Q without having to do a lot of work? If I wanted to do one more, then I guess 4.999, one more 9. There we go. Looking good. Now, you still have to do a whole load of YQ minus YPs. I don't know how to make your calculator do that for you, right? But at least don't you have the coordinates? Because they only gave you the X, but now you've got the X and Y. Can you imagine that this third column would have the slopes in it if you wanted? And that's the values that you would plug in. Are we good with that? Now, TI-84 is the one I use, as you can see. If you don't have one, contact Cheryl in the mesh office. So if you go to the mesh office, I don't have our email handy. Cheryl Phillips, CH, let's write it down. Right, so you contact her and she will give you a loaner, a TI-84 that you can use for the quarter. And she'll say, drop by on Tuesday and pick it up. And it doesn't cost you anything. Okay, so if you don't have one, you can beat up your little brother and steal it, because since it's the summer, he won't need it. I've had people said that they went to Goodwill and got really lucky and got one for $10. Yeah, that might be your lucky day, but you need one. Could you do this without one? I guess if you've got a basic scientific calculator, you can, but you won't be able to do all this cool stuff with tables, right? So if you don't mind doing a little bit extra work, you could probably get away without the TI-84, at least for this week. How are we doing, guys? Okay, so let's return one last time back to questions.
If we
Yes.
if we don't have a calculator, for this week we'll be fine doing that using Desmos.
If you can make Desmos do calculations, you're great, go for it. I would also look into, you can find calculator apps online. They'll do the job as well. The only problem I have with calculator apps is that, unless you've got two screens like I've got, it's a bit of a pain that you have to keep going out and in, just an inconvenience. There are alternatives. In fact, I think there's some TI-84 apps, aren't there, that emulate being a TI-84. That would be a perfect choice as well. So I'm assuming right now we're still looking at question 5. Is that what you're saying? Okay. So question 6 has a video and it takes you through a lot of what we've got. They just do the interval a little bit differently. And they talk about average velocity. Average velocity is the exact same thing with a different name as the slope of a secant line. So if somebody said, what's the average velocity from the 1 to 2 second mark, can you imagine that you use t equals 1 to get the y coordinate? And then t equals 2, you get the other y coordinate. So think of 1 as being your p, right? T equals 1 is your p, and t equals 2 is your q. And basically, you're just going to find a whole load of secant lines again. And they're just going to be called average velocities. And this one is similar to 7. This one is similar to 7 and 8. And this one here is also similar. So once you've figured out how to do question 7, the rest are going to be just other examples of question 7, maybe phrased slightly differently, but nothing too different. I think we've came to a natural finishing point.